In this video, we'll talk about graphing the cosine function. First, we should probably talk about some properties of the cosine function. So if we started at 0, like if we started at our x value of 0, or in this case it's x values are not x values, they're angle values, but they are along the horizontal axis, or the independent variable of the cosine function. You'll notice that the first point we get is up here at 1. Which makes sense. The cosine of 0 is 1. It's the x value. I mean, think about the unit circle, right? When you have an angle of 0, the x value is 1, the y value is 0. Okay, so you'll notice too that like it has these points. So sine had points where it started at 0, then it went up to 1, then it went back to 0, then it went down to -1, then it went back to 0, and that was one period. Well, cosine does a similar thing, except it starts at 1, goes to 0, goes down to -1, goes up to 0, and then goes back all the way up to 1. And that is one period. Okay, so from here to here, right, that's t. And t for cosine is 2 pi. The fundamental period of cosine is 2 pi. Also amplitude, right? Amplitude is still the same thing. It's like the height from the midline. It's like the height. Okay. It's also the, I guess, the depth. I don't know how far from the midline it goes down. That's still the amplitude. But notice it's all just kind of shifted a little bit. In fact, cosine, the graph of cosine is the same thing as the graph of sine. It's just been shifted pi over 2 to the left. Like you can imagine, like sine, I'll just draw what sine was. Sine kind of was, not kind of, sine was this. It went here, went that, there. So it did something along these lines, okay? And so it's the same graph, it's just shifted over. So, what does that mean? Well, let's notice a few things. We can break this up into 4 sections, just like we could with sine, right? So section 1, 2, 3, and 4. And also, like, it starts at 1 and it kind of does this decreasing at an increasing rate, so this concave down shape. And then it does, I'm sorry, I'm trying to erase this. Then it does this increasing at a decreasing rate, which is this concave up shape, right? It's concave up, it's concave down, concave up, concave down. And so if we just keep that in mind and we think about that this was our first point right here, and we're going to use our phase shift and our vertical shift to adjust that point, then all we have to do is apply the amplitude and the what am I saying? The amplitude and the period, so the horizontal compression. Have to see how the angular velocity, or the omega, affects the graph. So let's get into an example here. Okay, first thing, right away we can easily see that the amplitude is 2. Okay, the period, which has to do with the coefficient of the x, so omega is 1, and so for cosine, t is equal to 2 pi over omega. Well, if omega is 1, then the period of this function is just 2 pi. Phase shift, so there's nothing being subtracted or added to the x there, so there is no phase shift. And then the vertical shift is this 2, so it's been shifted 2 up. All right, now remember what we do here is we find the tick marks. So we have to find the tick marks, and we do that all the same way. We take our period of 2 pi, so we take 2 pi and divide it by 4. That is pi over 2. Okay, that means that our first tick mark's at 0 because we don't have a phase shift. The next one will be pi over 2 away from that. The next one will be pi over 2 away from that, so pi. Next one will be pi over 2 away from that, so 3 pi over 2, and the last one will be at 2 pi. So we can say that 0, this was pi over 2. Actually, let's do this in black. Pi over 2. This was pi. This was 3 pi over 2, and this was 2 pi. We could go further, and this would obviously be 5 pi over 2, okay? And it would keep doing the same thing. Now, we shifted 2 up, so our midline on this graph is going to be right here, okay? It's going to be a horizontal line kind of at y equals 2. Then, all we have to do is apply our dots because our period is normal. So we start up at the top, and so we went 2 up, right? Because the amplitude is 2, so we go 2 up, and we're going to be there and there. That's where we're going to have our points. So we have our maximum. That's where we start. Then our next tick mark will be back at the midline. So that's supposed to be over pi over 2. This is pi comma 0, then 3 pi over 2 comma 2, and then 2 pi comma 4. And then all we have to do is kind of draw in those concave up and concave down shapes that we saw previously, and it's going to do something like this. Okay, concave down, boom, switches to concave up, switches concave down, and then we indicate that it keeps going in this way by putting these dotted lines with the arrows at the end. And that's it. That's all we have to do for the graph of cosine. Now, obviously, there's some more difficult possible problems for this. We can have phase shifts and stuff. So let's look into a problem like that. Okay, so this one here is actually, we need to do a little manipulation before we're ready to go here, but the amplitude, right, the number out in front of the cosine is just 1, right? So the amplitude is just 1. We don't have to worry about anything weird going on there. We can handle the vertical shift right away too. It's just 2 down. Now, what's hard about this one here is we have our input. The input is x, okay? And what's being multiplied by x? That's omega, right? So in order to get x over 4 from x, we have to multiply it by 1/4, which means omega is 1/4. And if omega is 1/4, well, t is equal to 2 pi over omega. Now, it's only 2 pi over omega for sine and cosine because they have a fundamental period of 2 pi. Later on, when we talk about tangent, the fundamental period of tangent is pi. So for this one, 2 pi over 1/4, that is 8 pi. Right? That is the period of this, which is big. It's like it's 4 times the length of the fundamental period. Now, one thing that we can't right away say is that the phase shift is pi over 4. It's not. What we have to do here is say we have to factor out this 1/4 here. So we have 1/4 x minus pi. Right, if you factor the 1/4 out of what's in there. And so this function on the bottom and this function that was originally given to us, they're the same thing. We just factored out the inside. And what this does for us is it lets us see right away that the phase shift is pi. So the phase shift is pi and it's to the right. Okay, now let's look at the tick marks. So the tick marks. Okay, the tick marks, they are going to be at 8 pi and we're going to divide them by 4. And so they're going to be 2 pi away from each other. Now the first one starts at pi, okay, because we had our phase shift to pi. So we're going to have pi and then pi. I'm going to add 2 pi to that would be 3 pi. Add 2 pi to that would be 5 pi. Add 2 pi to that is some other 7 pi. I know how to do math. Plus another one, 9 pi. So there's our tick marks. Let's put them on here now. So we got one. Let's say if that's pi. Okay, then 2 pi twice that far. So we'll say it's like right here. That's a 3. Can you see that? And then 5 pi and 7 pi and then 9 pi is over here. Okay, so there's our tick marks. We also know we have a vertical shift of 2 down. So let's say that this is 2. Sorry, so it's -2 right there. Then we're going to go, if this is, so we'll say that's -1 and that's -3. So that's where we're going to have our stuff. Here's the midline, right? It's along the -2. Okay, and then let's put in our points. So its cosine source starts at the top, and we're going to be starting up at this is our first tick mark right here at pi, right? And we're going to be up at the top. So our first point's right there. Our next point is going to be down at the midline. Our next point is going to be down at the minimum. Then I'm going to go back up to the midline, and then back up to the maximum of -1. And then all we have to do is connect the dots. Smooth curve. So there's your concave down, concave up. Ooh, I missed that one a little bit. That's okay. Concave up. Done. And now just, again, the arrows to indicate that it keeps going. The arrows with the dotted lines. Because it's periodic. It keeps going the same way. So it's still the same shape. All right, one more example. Okay, y equals -5 times the cosine of 2 times x plus pi over 2. Okay, so boom, amplitude 5. Period, so omega is 2, right? So t is 2 pi over 2 because omega is 2. So period is pi on this one. The phase shift is pi over 2 and it's going to be to the left. The vertical shift, there isn't one. Okay, so that's nice. All right, so let's do this. We've got, let's do the tick marks. Tick marks, we've got the period is pi, so we're going to divide that by 4. That means each tick mark is pi over 4 away from the previous one, and we have a first one at pi over 2. Right? We have a negative pi over 2 is our first tick mark because it's been shifted over pi over 2 to the left. So add pi over 4 to negative pi over 2. We're going to get negative pi over 4. Then we'll be at 0. Then we'll be at pi over 4. Then we'll be at pi over 2. All right, so let's put these. Oh, I probably didn't draw this very well. Let me extend the x-axis a little bit here. Do a better job than that. Yep. How about that? Okay. So we've got tick marks on the x-axis. So let's say that is negative pi over 2. That this is negative pi over 4. The 0, obviously. Here's positive pi over 4 and positive pi over 2. Okay, we also have an amplitude of 5, so we're going to go up. Let's say 5 is way up here, 5, and then if we went down that, we have to go down that far too, to negative 5. Okay, the one thing we didn't consider so far is that there's this negative right here. What that does is it's a vertical flip. So whereas positive cosine starts at the maximum, negative cosine is going to be start drawing at the minimum. So if our first tick mark is here at negative pi over 2, then our y value there is going to be the negative 5, the minimum. So we'd be way down here. Okay. Then it's same pattern. Now it's obviously it's the opposite. So instead of maximum, midline, minimum, midline, maximum, it's going to go minimum, midline, maximum, midline, minimum. Say that 10 times fast or whatever. Okay, so here's the next point right there. It's going to be back up at the midline. Then we're going to go up to the maximum. Then we're going to go down to the midline. Then down back to the minimum. And all we got to do is draw in this. So we have this concave up first. Then it's going to switch to concave down. Or a happy face and a sad face. Big sad face. And then back to concave up. And we can just continue. We can draw on the dotted lines to say that it keeps going in this way. And that is the graph of y equals negative 5 times the cosine of 2 times quantity x plus pi over 2. You just got to be careful about your phase shifts, but everything else you can read directly off of the equation that's been given to you, and the process is exactly the same.